Sharing is a unique feature of Windows 8 and a key differentiator from the iPad. The general idea is that it stops one application's data from being siloed away from any other applications. Apps either declare themselves as being able to share data, able to receive shared data, or a combination of the two. The general idea of the approach is that applications register themselves as being able to share certain types of data. So data can be shared as plain text, RTF, HTML, bitmaps, files, or URIs. And the general idea here is that you don't declare a format, you just say I'm able to share plain text or I'm able to share bitmaps, and you allow the other applications to make sense of the data. So there isn't a sort of an idea of contracts here where you're able to do a specific sort of task. All you're really saying is that you can share data. This is similar to the DDE functions that used to be in very early versions of Windows. It is possible to share your own custom data, but I don't recommend doing this. The value of using sharing in Windows 8 is that it enriches each application as they're installed. If you say there has to be custom data that has to be understood, it implies you need specific applications installed. If you happen to be developing line of business applications, there are some arguments for doing this where you can allow the two applications to share. In order to handle outbound sharing, you need to use the Data Transfer Manager to tell Windows that you want to be asked for share data. When the user selects the share charm, your application will be called and you have an opportunity then to provide that data. The request handler is registered globally, and the first thing you need to do is dereference the current page. So in the demo we're about to see, I'll show you how to do this using an interface. When it comes time to actually share your information, you first of all need to send some metadata about the information you're sharing, which can just be a title and description, and that's what we'll actually do in the demo, and then you send the actual data. Let's now have a look at a demo. For this demo, we're going to be sharing some basic text. And what I've done here is created a XAML design surface with a text box with some text in it. The user is able to key any text they want into this, bring up the share charm, say they want to share, and that text will be shared with any application that understands text. The first thing we have to do is go into the app.xaml file and register the handler. So the way to do this is to find the on-launched event that Visual Studio will give for you and register it at the end. Now, there are a number of different features in Windows 8 that require this form of registration. So what I tend to do is break them out into separate methods. So here I'm going to create a method called setupSharing. I'm then going to create a method stub for that. And in here, I can register the handler. And this is done by accessing a manager, Data Transfer Manager, get for current view. To that I then create an event handler for the data requested event, which I can do using Visual Studio Autocomplete. What we have to do here is dereference the page which is active, and we're going to do this using an interface. So we'll go into the objects folder, say that we want to create a new class, which I'm going to call iSharingSource. Now I'm going to trim the namespace and I'm going to say that it's going to be a public interface, and at the moment I'm going to leave it without any methods in it because I'm going to auto create those when we come to use it. Going back to our app.xaml class, what we need to do is dereference the view. So I'm going to create a new method called getCurrentPage, and then I'm going to say if page is iSharingSource, we're going to cast it, and then we're going to say get share data. And what we've got given here as part of our event handler is a data requested event args object. Inside of that we have a request class, and that's what we're actually going to pass through to the interface. Let's correct that spelling there. If I then go into here and do generate method stub, if we go and look at the iSharingSource, we'll find that that method's there. Now I think that's pretty untidy, so what I'm going to do is get rid of that and then resolve out that namespace. And I'm also going to rename that to request so it's a little bit shorter. So then all we need to do now is build getCurrentPage. That's going to return a page instance, And we need to start by dereferencing the current frame, and then from the frame look at its content property and return a page. So in order to get the frame, we just do window.current.content, and we'll cast that, and then we'll just return page frame.content. And again, we're being very optimistic here, and there's no defensive coding in there, but most Windows 8 apps will follow this structure, so that should work absolutely fine. To see how far we're getting with this, what we'll do is we'll put a breakpoint on, and we'll run the application. And here's our application with the text, and we'll bring up the share charm, and we'll see our breakpoint gets hit. And we can go in and we can check to see that page is valid, but of course page won't be an instance of iSharing source because we haven't implemented that yet, so nothing will happen. When we actually go back and look at the application, the share charm has disappeared. So this is what Windows will do when you're doing stuff to do with sharing. Is it can be quite difficult to debug because it will keep optimistically hiding the user interface from you. If we take the breakpoint off and do it again, bring up the share charm, it will say there's nothing to share right now because although we have a handler, we haven't given it any data. So what we'll do is we'll go back and now add some data in. So on data to share page, we need to implement the interface. So we'll stop the application running. We'll say that we are of type iSharing source, and then we'll ask Visual Studio to implement that interface for us. I'll tidy that up again because it's pretty untidy. So now here's what we have to do is we have to send through the metadata first and then the actual data. Oops. If we look at the request class, we'll find that there's a data method and some other things we're going to look at. We're going to look at get deferral later because that's important, but we'll do request.data, and in there's a properties object, and this is what we use to define the metadata. So the first thing we'll do is do the title, and we'll also share a description. And that's the bare minimum of the metadata that we need to provide. And now we can go ahead and send through the data. So again, with request.data, we have a number of methods on here which map one-to-one with the types we saw earlier. So we can share bitmaps or HTML, RTF, storage items which are files, text, or URIs. So we're going to set the text, and the text we're going to pass in is the value of our text data. To be tidy, we'll trim the end. And that's all we have to do. So now if we run it, bring up the share charm, what it's done here is it's identified some applications which can share data. So if I pass it into QuickNote, so here's the description which I passed in, and here's some data. To show this works, we'll put some asterisks in. Bring up the share charm again, back into QuickNote, and there's the stars. When we're working with publishing shared data, we can't use async methods because what will happen is that Windows thinks when you drop into an await that the share process has finished. So what we have to do is use the setDataProvider to indicate that you intend to return data, and from within that method request a deferral. Deferrals happen a few times within the Win8 API, and in this particular instance this is called a pull request. Let's look at a demo. Here's our code as it was previously, and you'll see here that we're still at a position where we're sending through some text. What we want to do is we want to change this so that we create a file containing, let's say, 20 megs worth of data, which happens to be a copy of the text that the user put in. This is an arbitrary thing, but what I want to do is demonstrate the process of creating a large file and sending it back. So to do this, we'll create a method called createLargeFile, And into that, we'll start by creating a temporary file. So the easiest thing to do here is to use application data, resolve that through, current temporary folder, then create file async. There is no get temporary file arrangement like there was in .NET, so the easiest thing to do really is just to use a GUID to name a file and then just tack the extension you want on the end. So here we're just creating a text file with the name of a GUID. Now I've used await, so I need to do async. Then what we'll do is we'll say how big do we want it, and we're going to make a 20 meg file. And what we're going to do now is create a transacted file as we did before, and fill it up with data. So we'll open a transacted file stream. Wait, file, open transacted, write async. And now we need a stream writer, so we'll do var writer equals new stream writer. And this is a standard .NET stream writer, but one of the problems we have here is the stream isn't a .NET stream type, so we need to use the asStream extension method to make it so. Then we'll keep track of how many bytes we've written into the file. While we've written less than the size of the file, we'll write in the data. And the data, thinking about it, we'll pass it in through a parameter. We'll keep track of how much we've written. This code here will just go around and fill up that file to be the 20 meg that we specified up here. Now when we finish using the stream writer, we have to flush it, because in the WinRT world they don't automatically flush. So we'll just do flush async, and then we'll commit out the stream as we did before. And that's it. So then we can just return that file back. And you'll notice here I've got it as a void. And in order to return it, I need to return a storage file instance. But because it's async, I need to wrap that up in a task. And what's going on here? We need to resolve out system threading tasks. That's one of the things that I really wish they'd put into the standard templates. So now in order to call that, we need to get the data, we need to get our buffer out, which is going to be the text data text that we used before. File, we'll use this create.large file, passing in that buffer. And oh look, because that's an await, that now needs to be async. So it's at this point that things will stop working, but I want to show you what will happen when it does break. And then we'll just pass that through to the request. Request.data set storage items. And this wants an IEnumerable of storage items, so we'll just create a list. Passing in the file. Okay, so if we try and run that, that won't work because of this problem with async, but I just want to show you what happens when it fails. So here's our application. Bring up the share charm, hit share. This time there is a problem with the data from app dev sharing foo. So just to confirm that wasn't a glitch. No, so that's not working. So okay, so now we need to go back and use a deferral. Okay, so I was expecting to see a different error from the one that I did see, and I wonder what I did there. Okay, so yeah, when you're working with passing files back, you have to specify the types. What will happen is that and we'll see this when we look at share targets in a minute, when you want to share file data, you have to specify the type, because a share target can either look for specific types or it can look for any type of file. But without telling the sharing subsystem what type of data we're sharing, it can't match. So what we have to do here is go in and do request data, properties, file types, add, and it's a text file we're sharing, so we need to put that in. Now if you run it, we should get a better error. In this case, it goes through. This is some data that I've shared. That's interesting. Now that has actually worked, but it shouldn't work. So now if we do try and share that with mail, it has actually worked. That's very strange. Okay, so now it's failed again. Okay, so this is why working with Windows 8 at this point in the API cycle and being a V1 is hilarious, because that actually shouldn't work. It should fail and come up with an error that looks different. So let's try it again. There is a problem with the data from AppDev sharing food. So now what we can see is we've created something flaky. This makes it very difficult to get into doing this sort of stuff fresh, especially if you're coming from .NET, where the APIs tend to be more solid because it's so much more of an established platform. The reason why this isn't working is because it just happens to have been the case that the async stuff has managed to get the data in the right shape before it's shared. What we need to do is guarantee that it's in the right shape, which is where we use the set data provider and the deferral, which we'll go back and we'll now change. So what we need to try and isolate from here is we need to get rid of this await from being called and stop this from being async. So the rule is that this cannot be async, so we'll take that out, and then we'll get a compiler warning down here. This metadata has to be set up prior to us doing any work. This part here where we get the information from the UI, this has to stay in the main thread, so we can't move that around. So what we'll do now is we'll use a provider instead. And we do request.data, so set data provider. This is after a string format ID. Now, those of you who are used to using .NET will know that there's a thing called clipboards format, and there's a similar thing in WinRT called standard data formats. And in here, you can see bitmap, HTML, RTF, storage items, text. We obviously want storage items. Into here, we can pass in a Lambda expression. So we'll do async, the request, and we'll whack that right in there. So at this point, this is going to work more reliably. So the getShare method will complete synchronously because there's no await or asyncing happening here. So all of the metadata will go through, and Windows will understand that set data provider means it needs to come back and get that data later. The first thing we need to do, though, is get a deferral. And it's quite important when you're using a Lambda expression to use this request, not this request. So we'll use that one. And there's our getDeferral method. Now, the next trick we have to do is, we actually need to keep hold of the deferral. We then need to wrap this in a try finally, because when our work is finished, we need to call deferral.complete. And that's always the case when using these deferrals. As I mentioned before, in Windows 8, you get these deferrals come up a few times. So this bit now is not how we want to do it. So I'll just comment that out and keep it there so you can see the difference. Again, we use the request. This time we set data. And this takes an object, but because we're inside a set data provider, it understands what sort of data we're asking for. And again, in fact, to make it more explicit, I'll just copy that so we know what we're doing. Okay, does it build? It builds, but does it work? Bring up the share charm, go into mail. There's our file. So it worked the first time before. Is it reliable this time? Yes, it is. So that's great. So we can see now that it's consistently handling it. The one thing I do want to quickly drop in and show you is what's happening to that temporary file. So what we'll do is we'll go and find the package, which should be this guy. It's always fun. Yeah, I think these are the right ones. So our temp state folder at this point is empty. So let's go and... So what I want to show you here is that file's not being built until we use it. So when we bring up the share, all the metadata has gone through, so the share subsystem understands what data we're sharing. But if we go back and look at that temp state, it's empty because it hasn't been built yet. If we go back to the app, do share, and actually use it, so at this point, the Mail app has gone in and asked Windows to provide that shared data. The set data request has been used and it's gone through. Now if we look at temp state, there's our 20 meg file. And that's it.